Amines are the starting material for the synthesis of many substances like polymers and dye, stuffs and drugs. Amines can be classified into primary, secondary or tertiary amines depending upon the number of hydrogen atoms of ammonia that have been replaced by alkyl or aryl group. Amines are alkyl or aryl derivatives of ammonia and are obtained by the replacement of one or more hydrogen atoms of ammonia by alkyl or aryl group. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Now I am going to start a new lesson, that is organic compounds containing nitrogen. That compounds also we can call it as amines. In this session, we will discuss about introduction part of amines, classification, structure and also nomenclature of amines. Introduction. Amines are alkyl or aryl derivatives of ammonia. Okay. It may be for ammonia, it may be attached for alkyl or aryl derivatives of ammonia. In nature, they occur among proteins, vitamins, alkaloids and hormones. In nature, they will be occur among proteins, vitamins, alkaloids, etc. Amines are the starting material for the synthesis of many substances like polymers and dye, stuffs and drugs. Amines are alkyl or aryl derivatives of ammonia and are obtained by the replacement of one or more hydrogen atoms of ammonia by alkyl or aryl group. See here, if ammonia is like this NH3, in one of the hydrogen will be replaced by CH3 or any of the alkyl or any of the aryl group, that will be considered as amines. In this one, H is replaced by methyl group, so we will call it as methyl amine. Here 2 hydrogen will be replaced by 2 methyl group, that is why dimethyl amine. Here 3 hydrogens are replaced by 3 methyl group, so trimethyl amine. Okay, this is about amines. Next, structure of amines. Nitrogen atom of amines carries an unshared pair of electrons. Here in amine, it carries an unshared pair of electron. In amines, nitrogen is sp3 hybridized. Nitrogen is sp3 hybridized, all are single bonded. Aliphatic amines have a pyramidal shape, that is approximately tetrahedral, when we assume that electron pair on nitrogen group. In aliphatic amine, it is completely tetrahedral in nature, and above the nitrogen there is a presence of a lone pair of electrons. Lone pair electron is present. Each of the 3 sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon depending upon the composition of amines. Okay. The 4th orbital of nitrogen in all the amines contains a red pair of electrons. Due to the presence of unshared pair of electrons, angle between C and E, where E is C or H, is less than 109.5 degree. For instance, it is 108 degree in case of trimethyl amine. The pyramidal structure trimethyl amine is. Okay. Due to the unshared pair of electrons on nitrogen, the angle between carbon, nitrogen and carbon or hydrogen is less than 109 degree. Approximately it is around 108 degree in case of trimethylamine. It is having pyramidal structure in trimethyl amine. Okay. This is about structure of amine. Here the unpaired or unshared pair of electrons will contribute for the structure of amines. Next, classification of amines. Amines can be classified into primary, secondary or tertiary amines depending upon the number of hydrogen atoms of ammonia that have been replaced by alkyl or aryl group. In ammonia, if one hydrogen group is replaced, it will form primary amine. If 2 hydrogen is replaced, it will form secondary amine. If 3 hydrogen has been replaced, means tertiary amine. Okay. For example, trimethylamine. This is about general classification of amines. There is another category called simple and mixed amines. The substituents containing same groups attached to the nitrogen means simple amines. If it is mixed with 2 or 3 kinds of substituents or 2 or 3 kinds of groups, we'll call it as mixed amines. Okay, that is another category of amines. General classification is here based on replacement of hydrogen atom by alkyl or aryl group. Next, aliphatic amine, an amine in which nitrogen is bonded to alkyl group. See here, amine attached to alkyl group. This is methylamine, primary amine. This is dimethylamine. 2 methyl groups are attached, secondary amine. This is trimethylamine, where 3 alkyl groups are attached to the same nitrogen. That's why tertiary amine. Next, aromatic amines, an amine in which nitrogen is bonded to one or more aryl group. Okay, nitrogen group is attached to one or more aryl group. This is primary aromatic amine. This is secondary aromatic amine because one is aryl, one is alkyl, and here tertiary aromatic amine because all nitrogen are connected to alkyl or carbon element of alkyl or aryl group. And after this one, there is one more class of amines besides these 3 types in which nitrogen atom is quaternary. The derivatives of ammonium salt in which all the 4 hydrogen atoms are replaced by alkyl or aryl groups are called quaternary ammonium salts. Quaternary ammonium salts in which in ammonium nitrogen is surrounded by 4 hydrogens. Okay, that's why we'll call it as quaternary ammonium salt. Here C2H5N is tetraethyl ammonium chloride, which is the best example for quaternary ammonium salt. Next, nomenclature. We know that in 2 systems we can classify, that is common system and IUPAC system. In this system, in the common system, aliphatic amine is named alkyl amine as one word. In secondary and tertiary amines, when 2 or more groups are the same, the prefix di or tri is appended before the name of alkyl group. In this type of common name nomenclature, the aliphatic common will usually call it as alkyl amine. But if 2 or more alkyl groups are there, then we will substitute it as dialkyl amine, trialkyl amine, like that. In IUPAC system, the aliphatic names are named as alkyl amines. These names are obtained by replacing terminal E of the parent alkane by suffix amine. The substituents which are attached to the nitrogen atom is instead of carbon of the chain are designated by capital N. Names of aromatic amine. The simplest aromatic amine is 6,6-HYNH2. In common system, it will call it as aniline. Its simple derivatives are named using the prefixes ortho, meta, para or numbers to the locate substituents. While naming aryl amines, according to IUPAC system, suffix E of the arene is replaced by aryl amines. Okay. See here, in CH3NH2, 1-methyl, so methyl amine common name, methyl methanamine because in methane E will be removed and amine will be attached. Here isopropyl amine because it has been branched, or else in IUPAC name 2-propanamine. For the second position amine has been attached but overall propane is there, so 2-propanamine. This is trimethyl amine. This one N, N dimethyl methanamine. When more than one is there, N, N dimethyl. Okay. This is ethyl amine, 2 carbon atoms, and this one ethanamine. Here N-propyl amine because N number of series are present. So N-propyl amine. This is propanamine. Okay, at the first position. This is aniline. For ring NH2 is attached, commonly aniline. And this is benzenamine. For benzene, NH2 is amine group is attached. That's why. Next, orthotoluene. Because for at the ortho position CH3 is attached. But here 2-methyl benzenamine. Here para-bromoaniline. Because at the para position bromoaniline has been placed. In IUPAC 4-bromobenzene. Because from NH2 only you have to start numbering 1, 2, 3, 4. So 4-bromobenzenamine or 4-bromoaniline you can write. This one no common name. N-benzyl, N-ethyl benzenamine. Okay. N-benzyl, N-ethyl benzenamine. Okay. This is how we are going to name amine and its derivatives. according to IUPAC nomenclature. In the next session, we'll discuss about preparation of amines with its some of the properties. I hope you have understood completely whatever I have taught in this session regarding amines and its nomenclature and its classification. We'll meet in the upcoming session. Till that, thank you.